Hello everyone and welcome to another Tech Tip Tuesday. In today's Tech Tip, we'll be discussing GOM Inspect, which is a free inspection software that you can use to calculate different things like dimensions, GD&T elements such as flatness, parallelism, position checks, and even compare two different file types against one another to determine things like surface comparisons and material thicknesses, much more. So today we'll be going over some of the basic functionalities of GOM Inspect and how you can get started on creating your own inspection results for your next metrology report. So we'll go ahead by starting a new project in the software, which will take us to the inspection workspace. From here, I can start importing the different 3D file types that I'd like to analyze, and I'll go ahead by importing a CAD file in the form of a step file. So one of the workflows that we can take with the GOM Inspect is to compare an ideal CAD file to a different 3D file, typically a mesh file that's obtained from something like a 3D scanner that we use to create a digital copy of a physical part. So if we wanted to compare the physical part to the ideal CAD part, this is one way that we can do so. So I'm going to next bring in my mesh file, which was obtained from a GOM 3D scanner. And I'll add that to the part, and you'll see the mesh come in over here. So now that we have the actual file, which is the mesh file, and the nominal file, which is the CAD file, we'll have to create an alignment in order to position these two relative to one another to be able to get the results that we need. So to do that, I can create a pre-alignment, which uses a global best fit principle in order to reposition the two against one another. So now we see that the mesh file has been overlaid to the CAD file. And now we can start by creating our inspection results that we'd like to see. So the first thing that we can do is create a surface comparison plot, which will give us an idea in the form of colors, how much the surface of the actual file is deviating from the surface of the nominal file. So I can also apply things like a tolerance as well. So we'll leave it at 0.1 millimeters, plus or minus. And let's change the legend on the right to be smaller so we can get a better idea of the deviations. And now we see a full field color plot that represents positive deviations as red and negative deviations as blue. So positive deviation simply means that the surface of the mesh file is higher than the surface of the nominal file, whereas a negative value will indicate that the surface of the mesh is lower than that of the nominal. So if we wanted to get specific deviation values at certain points, we can apply deviation labels to be able to apply an exact value onto those specific target points, like so. So now we can see that our deviations sort of range within the values of 0.33 to about 0.31. I can also check a histogram to see how many points are contained within specific regions of deviations. So it seems that the majority of them lie within this sort of medium range of 0.15 to negative 0.15. And that's one example of an analysis that we can perform based on CAD files and mesh files in the software. Another thing that I can do is compare dimensions against one another. So if I wanted to compare, let's say, the diameter of the CAD file cylinder right over here to that of the mesh file right over here, I can do that as well. So I can construct a cylinder on the CAD file first, then create a similar instance of that using a fitting element to create a best fit cylinder on the actual mesh file. And now that I have two different cylinders that are aligned against one another, I can compare the diameters of both. And you can see that our nominal diameter should be 40 millimeters, whereas the actual calculated value on the mesh is giving us 40.11. So we're seeing a slightly larger diameter on the real file than what it should be on the CAD file. So these are just a couple of examples that showcase the different inspection results that you can calculate with the GOM Inspect tool. If you'd like to find out more information, please feel free to visit the GOM website at gom.com or get the CAD Micro Solutions website at cadmicro.com to find out more about this technology as well as the GOM capabilities. That's it for today's Tech Tip Tuesday. I will see you on the next one.